Admittedly, I'm a little bit excited because this cable that you can see exiting from my PC is actually connected to a CCI 101 capture card from Andor, and it connects to the more or less open frame Andor DV420-OE. Well, that's an open electrode detector chip that goes down to 200 nanometers. And as you can see, I just turned on the computer and saw that the fan was spinning. You know, as the fan is spinning, the product works. Well, at least part of it works. So I contacted Andor and they were a bit tight on the specs because this actually is an OEM product and they're not allowed to give out the specifics. In particular, concerning the connectors and the way the camera is being used in the OEM product. So I had to go from there. So basically I asked, well, I got a cable here, not mentioning that I did this myself, and unfortunately there's no other way with these housings to get the cable in because the cable is really thick. I used a lap cable that has 27 wires and it's really thick, so it gets sufficient cross-section for the Peltier cooling. At least that was the cable that was available, and of course it doesn't fit with the cable shrouds and strain relief, and yeah, so I omitted it for the tests. I'll have to go into detail with the cable at another point of time because the cable is very important for this camera, because this is just basically the analog end of things. And you can see it's actually a two-board construction, or at least the two main boards. On the back is the analog board, and it actually had a broken cable, so I had to fix that first. And on the other side there is mainly a collection of driver chips that drive the high capacitance CCD lines. Most parts are from Micrel and they run at very obscure voltages, so something like 0 and minus 15, something like that. Basically not your average 5-volt logic. At least the camera is being supplied with plus minus 15 volts and 5 volt from the PCI card. So I gather that the plus minus 15 volt is for the analog and the 5 volt is for the digital rail. And perhaps the minus 15 is also supplying part of the driver circuitry that drives the CCD chip. Moving on, you can see that there's quite a list of pins, and I actually tried and traced them out, figure out which ones are really important and really need to be low noise, and yeah, maybe I'll just show you on the So there are some signals that are important and need to be kept shielded from the rest, and in particular that is most likely the clock, and yeah, as far as the differential analog signal goes, it's the signal itself. It's buffered and then sent out with proper termination on the other side. And this is what really got me excited now, because as you can see, this is Maxim DL, that's telescope software that I found on the internet, and it happens to be supporting the Andor camera. And I just, you have to install the available Andor driver, and then and you have to copy the DLL and the driver files to the Maxim DL directory. Then you can select an initialization file, and yeah, apparently it has, once you click Discover, found an Andor DV420. That's quite exciting. By the way, I just have to clean up my desk, and this is the 26-pin HD D sub connector. Female and male versions, and they hardly anyone uses them, so they're not that easy to come by. And those are the Molex connectors. As you can tell, this is the 2x2 and the 2x6 connector, and this just connects to the back of the PCB by default. So perhaps there's a buzzer that has to be attached for over temperature warning. I don't know. No one will tell me. And this is for the Peltier connection. The Andor supplies actually an external power supply that is used to get maximum cooling power when you're also using liquid cooling. But the camera can run off the PCI card itself when you attach the external 4-pin Molex connector that supplies the 5V and 12V to your drives in the computer. This may get a bit blurry, but I'll try anyway. Now, up here, unfortunately, it's disordered. There's 60 NE06 P-channel MOSFET. This is an optical relay, and this is a 1 ohm resistor. So via the 1 ohm resistor, the Peltier 5V net connects to the externally supplied 5V, and the FET just turns on and off the Peltier element. There's no DC-DC converter that linearly regulates the Peltier to get regulation for the temperature. So it's not that precise. And there's the rest of the stuff as an Altera Flex FPGA and some sort of PCI voltage level conversion and interfacing chip. Might look that up. Maybe it's also a complete PCI master and slave device implemented on this chip. And there is it's an AMD part. It's a AM29200 20kc. Well, that may also be just programmable logic. So yeah, those are the Datel DC-DC converters, and this is the memory that's tied into the Altera Flex. So that's going to be doing the image acquisition and buffering. And on the rear side, that's where you get your probe points for the DC-DC converters, and yeah, there's some red-necked LDOs on the back. There's the AD converter and DAC, and yeah, that's an analog chip. The extension head of the 15-pin high-density D-sub connector is actually fully specified, because that's the external connector to which you can connect shutter and sensors and trigger signals. So that's actually a handy little connector that you can use to automate your, at least to complete your image acquisition setup. So this most likely won't work because I never tried it, so I can't promise. But anyway, we'll do it live on camera. Let's click OK. Click OK here, and then oh geez, I don't know what I have to do. Is there anything like live view? I have no clue. I have no clue how the software works. Alright, give me a sec. So I clicked on connect. There is cooler. Turns on camera coolers. Oh, would you look at that. Sensor temperature. It appears we have a sensor temperature. So how about you give me some picture? Okay. We get a picture once the cooldown is complete. I recall that at least in Andor Solis you could get a live view, or you could get updated views even when the camera was cooling down. But as you can see, jeez, it's working. Look at that. We're cooling down. We're cooling down. And as a matter of fact, cooling down is provided by these two short circuits. You see the wires come off the rear PCB of the camera, and they just break out into this connector that's proprietary something. Yeah, I just tend to ignore that because it's no use to me. It's just it was used in a UV Raman or UV vis Raman spectrometer assembly, and maybe this camera was just pulled from the assembly. So yeah, those two wires, they just come back in, and they have a few ohms resistance, and they just connect to a Peltier element